going to go over the Unit 1 Number Systems Assessment. So we have our first question. It says, which value is equivalent to 0.14 repeating? So I'm going to turn on my drawing tools. I know that I have two numbers underneath the decimal, underneath the repeating line right here. So I'm going to have x equals 0.45, and I know that 100x equals 45.45 repeating. So my next step is to subtract off the part that repeats. So I'm going to do minus x and then minus 0.45 repeating. So I end up with 99x equals 45. And then from there, I have a one-step equation. So I'm going to divide by 99 on each side. So I have x equals 45 over 99. If I look at my answer choices, that's none of them. So I know I'm going to have to reduce my fraction. I divide by 9, and I get 5 over 11. I also could have divided each of my answer choices into the calculator. 5 divided by 11, and I get 0.45 repeating. So C should have been my answer. For the next one, I have to think 8 and 9 are my two values. So I'm going to figure out what cube fits between them. So cube means I'm multiplying by 3. So I'm going to do the same number 3 times. So 8 times 8 times 8. And I get 512. So whatever the number is has to be between that and 9 times 9 times 9. And I get 729. So it has to fit between those two numbers. And the only one is C. Which statement is true? So I've got two square roots. So I'm going to start with the square root of 6 is going to be between the square root of 4, which the perfect square is 4, the square root's 2, and then the perfect square of 9 and the square root's 3. So I know I have to do 6 minus 4, and I get 2. And then I'm going to do 9 minus 4, and I get 5. 2 divided by 5, I get 0.4. So I always take the smaller of the two square roots. So the square root of 6 is less than or equal to 2.4. All right, which number is equivalent? So I'm going to cross off this part for right now, and I'm going to come back to it. So I have x equals 0.42 repeating. So I know that 100x, because I always do based on the number of numbers underneath the line, so is equal to 42.42 repeating. So I'm going to subtract off x and subtract off the 0.42 repeating. So I end up with 99x equals 42. I'm going to divide by 99. And I end up with x equals 42 over 99. If I look, none of those have that answer, but I know 3 goes into both of these. So 14 over 33. So I know that that's going to be my fraction. And I have to remember my whole number. So I'm going to check that. And I get the 4-2 repeating. Which one is an irrational number? So I remember that pi is irrational. I remember decimals that go on forever with no pattern. So like 3, 6, 2, 7, 3, 8, 9, no pattern. And I know square roots of non-perfect perfect squares. So that's going to be, so this is rational, this one's rational, and 25 is rational because the square root is 5. So C should have been your answer. For this one, I have two numbers between 60. I'm looking for the two integers where it would fall. So I know it has to be negative, so it can't be B or A. So I know that I'm looking for two values here. I have my perfect squares are going to be 49 and 64. So that's 7 and 8. So that's going to be these two. And I knew that because you had access to the multiplication chart. Okay, which rational number can be converted into a fraction? So I'm looking for a rational number. This one is irrational because it goes on forever. This one has pi in it, so it's irrational. This one is a non-perfect square, so that one's irrational. This can be converted into a fraction. All right, so I'm going to do 21 divided by 495, and I get 220 divided by 4909. And then 19 divided by 441. And they want least to greatest. So that means I got to start with one of these two. And then I got to have the 19. And so it's got to be B. All right, for this one, they want a repeating decimal. So I know that I have one number underneath the decimal point. I'm sorry, one number underneath the line, two numbers behind the decimal point. So that means I have x equals 0.38 repeating, and I have 10x equals 3.8 repeating. So I'm going to subtract x, and I'm going to subtract 0.38 repeating. 9, and I end up with equals. This is the part where I have to put in my calculator. So I have 3.8888 minus 0.3. So I get 3.5. I'm not being very patient. Now I'm going to divide by 9. So I end up with x equals 3.5 divided by 9. Now to change this back into a fraction, I can't have this decimal point here. So I'm going to have to multiply each of them by 10 to move that decimal point over. So I get 35 over 90. And then, so I end up with, what's 7 over 45? Oh, they didn't want us to reduce it. They kept it. 35 over 90. All right, next one, same idea. I have x equals 0.018 repeating. So I have 100x equals 0.018. Sorry. I got ahead of myself. 1.8 repeating. Because remember, you're moving that decimal 2 places. So even though it doesn't look like it, that phantom 0 is still like right there. Okay, so I'm going to subtract x, and I'm going to subtract 0.18 repeating. So I get 99x, and then I'm going to use my handy dandy calculator. 1.818181818 minus 0.018118181818, and I get 1.8. Divide by 99. So I end up with x equals 1.8 over 99. I have to multiply by 10 on each side. So I end up with 18 over 990. They did want that one reduced. So what's 990 divided by 18? 55. 1 over 55. And let's just double check that to make sure we're correct. 1 divided by 55. Yep, it works. Okay, between which two numbers does the square root of 5 lie? So we have 4 and 9. So that means 5 minus 4, we get 1. 9 minus 4, we get 5. 1 divided by 5, 0.2. And then we're going to always use the smaller of the two square roots, so 2.2. So we can eliminate this one and this one. So now we're stuck between these two options. All right, so let's try this one. Square root of 5. We get 2.23. So it's definitely not going to go down. All right, for this one, you have 7 divided by the cubed root of 8 is 2. So that works out to be 3.5. So anytime you have a fraction, it is a rational number. A integer would be a negative or positive whole number. A natural number would be all of your whole numbers that are positive and it doesn't include 0. Irrational would be like pi, non-perfect squares, and decimal points that go on forever. Okay, card game that has all rational numbers. So that's irrational. That's irrational. Irrational, 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 irrational. So the only one that was completely rational was Ben. So you have 0.03 equals x, and then you have 10x equals 0.3 repeating. So then you're going to subtract x, and you're going to subtract 0.03 repeating. So you end up with 9x, and then we're going to put that in our calculator. So we end up with 0.33333 minus 0.0, and we ended up with 3/10 divided by 9. So then we end up with x equals 0.3 over 9. So we have to multiply by 10. So we end up with 3 over 90, which works out to be 1 over 30. All right, the value of the square root of 6 is between the whole numbers 5 and 7. Well, we know that the value of the square root of 6 is going to be less than 3 because the square root of 6 is going to fall between 2 and 3 because it's going to be between 4 and 9. So the value of 6 is between 2.43 and 2.45. So I agree. It should be 2 only. And the last question, which of the following is closest to the value of the square root of 11? You should have done 9 and 16, 3 and 4, and then done 11 minus 9, 16 minus 9, 2 over 7. The 8 tells the 2 to round up, so it's going to be 0.3. So it's going to be 3.3. All right, if you have any questions, let me know before you retake. Remember that to do a retake, you have to have all your corrections, and you need to have studied before you do the retake. All right, I hope you have a great rest of your day. Bye.